Hi, Big Data Conference. Welcome to today's speech. I'm Jörg from TrustBit, and I've brought with me today Sana Rasheed. She's a lead data scientist at Accenture, and I'm very blessed to hear your talk today, Sana, about industrial use cases of data science. Sana has worked in the beginning as a software developer, as many of us, but has soon switched over to data science because she loves working with data to dig deep into that data. During her talk today, we will hear about two different use cases from the industrial. One will be the retail from the retail industry, and the other one from the automobile industry. I guess you are also looking forward to see what Sana will talk about us. And Sana, please take over and show us your insights.
Sure. Thank you very much. Hello, everyone. Just give me a second to share my screen. Okay. Somehow it's not showing my presentation. So, guys, I'm Sana Rasheed and I'm a lead data scientist at Accenture. Today, I will be speaking about data science and industrial use cases. A bit about what we are going to discuss today. So, I will introduce you a bit more about myself and then my Accenture family, and then we will set up some expectations. And then I will be talking about what is the data, who is the data scientist, and we will walk through the data science process which we follow. And we will deep dive into the two use cases. One is from the retail industry and other is from the automobile industry. And then I will open the floor for the questions. About me, I'm a code developer by heart and I have expertise in the domain of data science, predictive analytics, visualization, and deep learning. To participate in competitions like on Kaggle, and in my later time, I also like to practice new algorithms as well. A bit about my clients. I have worked from USA, from Saudi Arabia, Sri Lanka, North Korea as well. I'm author of a couple of books and I have few publications as well, and I have won few awards as well. And about my Accenture family. So Accenture providing strategy, consulting, services and solution. We are a family of like 0.5 million headcount. Multiple wings, for example, internet, blockchain solution development, the main head of technology, and AI domain, which globally have the headcount of around 12,000. If we focus on the Baltic region, then we have like near 200 talents in the. Before moving on, I like to share the poll with you and request you guys to take a 30 seconds and vote for it so that I would know what is your expectation today's session. So I would try to keep my talk more related with that. So it would be a learning as well. So guys, just I have a few seconds and the options which brings you here. Wow. Most of the words goes to industrial use cases, so that is the right place. I will be sharing these insights with you. So let's continue. I would start with the data. The era of digital data generation, and we produce a lot of data. And over here, we have the understanding of the data as well. We have to generate that understanding. So data is useless and can be or should be misleading without its context. So it's very important to understand the context of the data as well. For example, let's take the example of 60 to you. Yeah, 60 could be a speed limit or age or blood pressure or mile per hour. It could be anything. So we need to define what is the 60, right? And then let's say 60 is the age. And then we need to define the context in terms of the region or other contexts as well. So for example, 60 is the age and we wanted to look into the uh, Nigeria or Ethiopia. So let's say in Nigeria or Ethiopia region, the life expectancy is 54. Over there, 60 is misleading, is misguiding. So if we talk about life expectancy in USA or Canada, then the life expectancy is 84. So over there, again, it's misleading. So we really need to define their context, because context actually help us the story. So data needs a story to tell a story, and that's come from the context as well, from which context it's accurate and which context it's not. And then, to be honest, for me, data is like a color to me. I have a canvas of with different colors, data from the different domains, and with that, I can create a good thing as well with a lot of different colors of the data. And about who is the data scientist, we know that what data scientists do, but who are they? So the data scientists are the one who understand less about the science than the one who creates it, and the little less about the data than the one who generates it, but exactly knows how these two work together. So in order to provide the solution to the business problem or any social issue, one who better need to understand what science to use it to in order to solve that problem. Data science is the one who thinks outside the box, become the box as well, to propose the best side for any problem which exists. Data science process flow. This is the data science process flow we follow. We start with our client discussions and try to understand their business, what their problem is, what the context of their problem, etc., and what their expectations are, what their objectives, and then we move on with the data acquisition and understanding phase. It has the sub phases as well, like data source. Data source is about where the data is lying, what type of data we need, what dimensions we need, and talking about the pipeline like either we would be receiving etc. Then it comes to environment, like every client have their own infrastructure, prepare something which can be deployed in there, or we can have a cloud-based solution separately. Start with the data wrangling, cleaning, analysis, etc., and then move to the modeling phase, where we perform the engineering, model training, and model evaluation, etc. After the evaluation, we are satisfied with our results with different iteration, because data science whole process is iterative, not only inside one of the module, but in the overall process flow. Then once we are satisfied, we go with the client in the discussion and show that our results, these are good enough. If they are convinced and happy, then we go forward. And then once everything good, and this is the process flow we follow. So let's start with the case study we wanted to learn in today's sessions. Deep dive more into here, and we will spend some time. So the very first one is the case study of order cut from retail industry. Let me explain you the problematic scenario first. Consider there is a wholesaler X who wanted to buy product A, and they request to the vendor, and at the they have the order management analyst who look into the inventory and confirms to the wholesaler that we would deliver your order in full in next 7 days. Full is important to remember. So they notify him. In the meantime, and other wholesaler come in and they requested this product A, and on some, for example, because they requested the less amount. And again, after the verification, uh, wholesaler Y has been fulfilled. And then for the wholesaler X, the shipper was arranged to pick up the order. And at that time, the shipper would able to identify that in the inventory at the warehouse, the items are reduced, is not the full item. So that is the order cut. For the order they received was high, but the shipment quantity is less. That's the order cut we say. So a bit more about context. The client sees a cost of more than 100 million USD per year directly connected to order cuts. Due to ever-changing stock level, a high impact is felt in production and stock planning. And due to retrospective nature of this issue, the client is unable to address it before it happens. Solve this issue with our client, this is the approach follow. So there are the three stages. The very first stage is we go into the exploration phase with the client and try to understand their challenge and align the expectation on the project. The second is we arrange and execute a design thinking workshop where we have representative from the Accenture side and from the client side as well. In that workshop, we have different we were able to see the expectation, their needs, everything, and on the same page at the end of the workshop we will be producing, and this is what you are expecting together. And in stage 3, all the knowledge we gained in the previous 2 stages, and we start our process and we build the solution in the landscape of the client, whatever infrastructure they have, and then we validate our approach and the benefits of our solution. So this was the scenario after having having this session with them. So for example, let's explain you, this is the whole ecosystem they have. For example, sales item, sales order request, and that's come into the very first processing. Over here, the order map of those and then they pass it to the transport plan. They do the optimization of the blocks, everything, and etc. And then they execute the tender notification after accepting everything. Once the carrier arrives the order, at that time, if they see that the order is less than the order, the shipment order is less than the actual order, that's mean the carrier is going off half unloaded. That's mean vendor has to arrange another carrier to get the remaining once they have the inventory in house. So that was a huge cost on the client's pocket. So let's click on this first phase because we wanted to propose to they were able to identify. So it's better if they have something in the beginning. Over here, when we did, we were able to understand that the first phase also have sub phases as well. And when they receive the order, there are 2 types of as well. One is the incomplete, which they are in the process of submitting, let's say, and the other one is might also come back every passing day and say that they won't item, they are dropping it. So let's say they ordered 10 items previously, now they say, okay, just send me 7. They have just reduced it. So again, order management analyst has to redo the optimization of everything and again send out to the transport planner, and they redo the planning for those reduced blocks, etc. So it's an iterative process and very, very time consuming as well. So over here, we think that how about if we have a predictive model integrated somewhere here, and they would know that these are the items where they might face cut or not cut. Based on that, they can do a better optimization. So for this phase, what we propose them is, let's have a separate module, cloud-based, and the results we would able to generate, that should get integrated with your own system. So we would not affect what they are comfortable at, because if they are using a system, it's a very long time they are using it, and it's better if we propose something on their own infrastructure. So we propose a standalone module which work separately, pick up the data, do the prediction, and the results will be submitted to the or with the system, in the system of the auto acquisition, and the analyst would able to see, and based on that they can do the optimization of the blocks, etc. So now let's talk about this auto predictor. First of all, we set the objective. It's very important. So we set the objective, what we wanted to achieve. The objective we set was to forecast the occurrence of cut on sales item. So on the sales item, we wanted to predict the cut. So it's important to understand the definition as well. And to reach to the definition, it's again a two-way communication. We cannot set by ourselves. With the client, we define this definition of the cut and we followed it. So the definition we picked up is the shipped quantity less than the actual order quantity. There's the cut. Two scenarios. One, quantity, shipped quantity. Either we do not have inventory at all, and at that wasn't able to send out, or the shipment or quantity has get passing day, that also the order cut. And that other case is that we have less item in the inventory. So over here, the major influencer is the inventory availability. Or if we have a snapshot of for first few days, that also contribute a lot to know either there would be the cut on the sales item or not. So in terms of the predictive model, very quickly, this is the basic process by model building, which we divide into training and validation set. We do the factorization, correlation, and model, and we do the validation as well. And then we move it into the new data set. In terms of the data sources we used is the of all sales order details, when it received, what is the expected time, how many items are needed, etc., etc. Then another dimension related with the order cuts as well, the shipment details, from where it should be picked up and sent out, etc. And the more important are the inventory snapshot at the time of when the order has been placed, and the important one is the arrival schedule of the 3 to 5 days as well. We have collected, and more important, it was in SAP. So whatever we were building, that the infrastructure they were using, we should be providing those services in their infrastructure. So in SAP, we use the SAP services. There are 2 KPIs which mainly used for building the model. So these are the scoring equation API. But you always come with the issues. So we were able to identify the data quality issues. For example, over here, order quantity cannot be decimal; it should be the whole number. So there are a few other issues. There were values with the negative values. However, it should not be. And we identify these issues to the client, and they improve their ETL process, and they rectify these issues. And once we receive fine data, then we move on with the correlation analysis, and we drop the highly correlated variables. And then we quickly perform the key influencer, where we were able to identify which variables are significant. And based on those input model, we have built the model. with where we receive 83% of the accuracy, with the confidence of the model is like 98%. So this whole process, as we was trying to predict the cut, definitely it has the issue of the imbalance class. So we spent more time on the resampling techniques as compared to the model building, because as you know, whenever there is the class imbalance factor exists, we need to take care of that before the model building. So that's the whole process we have followed, and at the end this is the minimum viable product we have produced. So they have the tool where they have all the details of the sales item, sales document, when it's created, submitted, how many items are needed, etc., and what are the confidence level that either they would receive the cut. So red are the one where those items may seem to be faced cut, either because of the client or because of the inventory at the background. And once they click on it, they can see more details on it. So this is the minimum viable product we were able to produce based on our predictive model, and they integrate it in their analyst system. And in terms of value generation, was able to capture 83% of, so it resulted in tremendous saving we're able to generate for our client for this particular so now you have the idea of how the whole process from A to Z, how we go into the discussions with the client and try to develop the understanding and reach to satisfaction of our client as well. So now jumping to the next use case, which is automobile industry. It is early warning system, and to be honest, it's a very different one, and I like this one most as compared to our traditional use cases. So okay, so let me explain the scenario here again. As in nowadays in automobile, in vehicles, companies are providing internet. They receive some data from the vehicle as well. That we serve two use cases. Something if goes to the workshop and then they create that case, or they can create their case on the system by themselves as well. Based on that, what was happening, they were the call from the call center, and they guide them how it should be resolved. So what we try to do the use cases, we try to build the automated intelligence solution mapping. So if certain fault has happened with these issues which driver has identified, automatically try to recommend what a good solution that would be, and we propose them recommendation of the solution. The other one was, if any fault code is higher than a certain threshold, subject matter expert wanted to know those so that they can better propose offers to their customers, or better to rectify those by going in discussion with the manufacturing wing. So that I'm going to speak here. So early warning system. Again, process flow, we start with the business understanding and then the data acquisition and understanding. And for this particular use case, we have built in Azure Microsoft. We used Microsoft services to build the model, everything. And we go with the model building and do the deployment as a web service. Of the early warning system, over here, the objective was to automatically trigger prospective quality issues, quality cases based on identified patterns representing reoccurring problems or symptoms. So what we did here is we capture all the data set we have with the fault codes with different attributes, could be the brain driving attributes or other things. And based on that, we are giving input this to the machine learning model and wanted to generate the business rule which machine propose, because if analyst is doing the analysis, they can only look for 2 or 3 variables, or maybe 10 or 15. So whatever rules will be generated, it will parse to the it will parse to the SME, and they will assess it. And if they are satisfied, then they would parse it to the deployment system, in the system deployment. So over here, customer value is created by capturing a potential quality issues in the phase to avoid more serious issues in the long run, so that they can offer better solutions or offers to their clients as well. So here is the data preparation. For this data, one thing which is different is we have considered publicly available data asset as well, because that give us a good sense to make more appropriate or more useful insights for the model. So over here, the data we receive from the client with that available data set. Over here, the weather data, and important to understand if any to the vehicle, either the indirect effect or it could be because of the road conditions, and those things. So we the topography and the weather, and based on that we did the analysis. So what was happening at that time at the SME side? So they have simple the Excel sheet and trying to doing the counts of how many fault codes has been occurred in which month, etc. And they are actually generating the rules. If in a certain month, like that fault code more than 7 times, then it's alert. If it's equal to 7 times, or it could be or between 5 to 7, then it's the notification. So they are doing it based. So consider that you have a data set of 50 attributes or more than that, then obviously, and consider all of them all together with different combinations. So it was recommended that to have a machine learning model which tells you what rules we could use or deploy based on the occurrence of the fault code. And that's where we have proposed them, like we have provided them the dashboard. Faults are occurring in the real time, and this is the threshold, and these are the rules. If anything goes above the threshold, the SME would notification in their system, and they would review it, and after the assessment they can deploy it into the system. And if everything goes afterwards, they know that now these are the client they need to. So this is the for them, and at the end the value this particular client is increase matter expert satisfaction, then definitely it leads to the customer satisfaction as well. And on the other side, the quality issues notification, which are getting high, some fault issues, they were able to notify them to the manufacturing wing as well. So they have captured the satisfaction as well and try to improve their product as well. Value we have generated for them. Hold on, this is not it. So I would like to share with you as we are doing here at Accenture as well. So just quickly, briefly about, so that you would get use cases, and if you wanted to speak about it, you can come and ask as well. So in the Liquid Studio at Accenture, we try different new technologies, and we try to build new ideas related with the data, AI, everything. And over there of the use cases, the very first one is the fashion advisor. You can consider it as a virtual dressing room service as well. So over here, what you do, you will upload your image and your picture, and then you can try different outfits on your image and see how it looks. And from there, you can select. So that is the fashion advisor use case we have. Another one is the anomaly detector. It's a anomaly detection. It catches the abnormality inside the data flow, and the data be from the audio, text, or image. And the third one is from the medical domain, healthcare, very medical recognition. Over here, we have applied the computer vision and deep learning techniques in order to capture, recognize the different pills. And the third one and the last one is personal protective equipment monitoring. So for working in construction area or in hazardous condition, we are actually monitoring them, how well they are equipped, how well they are safe while doing their job. So these are the few quick use cases I wanted to just highlight. If you wanted to discuss and have questions, then you can definitely come and ask related to these use cases as well. So guys, thank you very much. I'm glad that I'm ahead of time. So for the question sessions as well. Like if you want to ask question related to fashion, education, or insurance, you can as well, and definitely with the use cases. And if you like to explore more use cases, you can also join us today in our virtual booth session, which is at 3:30 CT time. So you can join over there, me with my colleagues, and we will definitely help you with your queries as well. Thank you, everyone.
Thank you, Sana, for all that insights that you have had so far for us. We have a few questions. So first, I want to ask you, during the use case of the retail industry, you have mentioned that you have done a design thinking workshop. I wonder how a design thinking workshop looks like when you have a problem that you want to tackle with data science. Maybe you can tell us a little bit what we can think of a design thinking workshop.
What happened in the design thinking process is we have one from the Accenture who is actually leading it with asking different questions. So come into the room, they have a lot of problems. Solve all of them with one. So we wanted this design to segregate what specific problem you wanted to solve, and with common mutual understanding, that's what we are going to build. So those starts with the question, what problem do you think you which is the most important one you want to address at first. They come up with a, and they will do the voting that which one is more, because from the client side they have like 5 to 6 representatives. When they do the voting, they see that yes, this is the very important, let's figure out this one, and that solution help us to fix the next one as well. So that's how it starts. And on the second day when we discuss about the solution, this is the solution you wanted as a product, as a site or web or desktop application or mobile application, or what sort of solution you are looking forward. And then in the third day it's more like we do the design, a prototype of what it should look like, how you are assuming it should be reflected as per your ageness, because it's very important to consider the ageness of the client as well, because ultimately they would be using the tool as well. So with all those knowledge, what they are thinking, first it helps us to segregate to the reach to the very narrow problem they wanted to solve, and which has the priority, and what solution they are looking for, and how they should look like, how it should system, etc. And over there we discuss what technologies they have, what should we can do with that, and how we can work out, because that also give us understanding at the Accenture side if we need other resources on board as well. For example, if they say that they wanted to build a mobile application, for example, for the SAP infrastructure, then we would be getting on board a resource would help us to get that specific part done with the predictive analytics services. So this is a session with a lot of questions, with the workshop, like sticking different notes with got the priority, etc. So that's help us to reach to the point where we have a common understanding of what we are going to build.
Great. And how many people do you bring into that room, or up to how many people would you say does a design thinking workshop work?
So to be honest, it's more like the their domains should be there in the room, so they as well if they're looking for this solution as well from different domain as well, like data data scientist, application development, because those are as well. Because being a data scientist, I may forget few very important things from the application side or the client applications. So a few heads of those should be there, because rest of the team can be briefed later on. And from the client side, they should be the managed leaders who really wanted actually bring us to this project and say that these are the issue we are facing and this is how we want you to solve it. And they also bring in their analyst as well, who will be using that platform. So that is also important.
Okay.
In terms of number, I can't say, but that's, I think it's depends the product, but definitely it should be the main.
Okay, thank you. So we have another question regarding SAP. I think it was also in the first use case about retail industry. And the question is, how do you access the data that is stored in SAP? Which tools and interfaces are you using to access this data?
So in the SAP data warehouse, we have used and Fury application we have built at the end. So the end minimum viable product we have showed you is built in the Fury application, where we were showing the results. But at the back end, SAP predictive services we have purchased in the sense for that. In terms of warehouse, if there is, I'm sorry for that, I'm not very much familiar with a lot of, but we have the SAP in the team who would help me to fetch these data from there. And when it comes to deploying the of using those APIs, then again a developer supported me on that to do that.
Okay.
That was the end application in the Fury application.
And we all know about the difficulties running data science tools and operate them on premise, and what good things are there in the cloud services, on the managed services. Do you use the cloud services for exploration? Do you upload the data there? How you are tackling the problem with anonymizing the data? How do you work with sensitive data?
So for the sensitive data, once we start the project with our client, we definitely sign a lot of documents, confidentiality, etc. And then they give us access to their system, limited access to either they can create a dummy data for us to work on at the moment. So they create a separate limited cloud infrastructure for us with limited access to the data. They just create a dummy database for us, and from there we just inform them these are the things we need, and they create the ETL process, and that's get deployed in over there. And most of the time when we work with the client, they provide us access to their systems after signing all of these things and giving us the training. Then over there we start using their cloud infrastructure, and from there over there we start building it. And in terms of sharing the data, it's again everything is on the cloud, nothing is on the system. We used to do it on the cloud. The cloud access either provided by them or provided or by the Accenture, and where the data should reside, and we should build model over there and go in a discussion with the clients over there.
Okay, great. And there is a question regarding the automobile industry. The question is, what is the area that you have invested most of your effort to solve the problem? Was it more about exploring the data, getting the data, preparing the data, training the model?
To be honest, the data preparation and exploration. The problem we were trying to solve, look into the dimension of like indirect variables which have effect on this scenario. Over there we spend enough time in order to see if we can find out some more good data which help us, or at least to identify why these issues are happening, what are the reasons of happening these issues, that give us more exposure to tell to the manufacturing companies that thing is still happening, but these are the reasons which we were able to identify. Definitely they have their own data set and details over there as well. So most time we spend on the exploration, getting the data, connect, bring the public data with their in-house.
And which tools do you prefer to train a model? Is there any specific tool at all, or does it really depend on the problem that you're tackling?
It depends on the infrastructure, or to be honest, because being a data scientist, you can have all these skills by having the skills of programming languages like Python or R, or it could be Databricks or anything. But when you go in a specific industry, company, let's say, then the company has its own infrastructure which we have to work on. We need to learn those technology. So our own learning we can do in any language, but when it comes to delivery to the product of to the client, we consider their bandwidth to where we can, and we also help them in their transfer to shift from one infrastructure to an enough knowledge, etc., training, because it's not just a switch another, because it would be hard for the client, because ultimately they are using it, and if we are proposing something which is very new, then it would be hard for them to maintain.
Okay, I have a last question. As you have explained to us, you have worked in many different projects, so you have seen many things out in the wild. And would you say, how is this nowadays bringing models into production? Is it still more the classical IT to hand it over the model and please operate it? Or are we currently driving through, as an industry, more to specialized pipelines to deliver these models? What are your insights on that?
Again, it highly depends on the client's preferences, because it depends on the infrastructure. For example, the clients I have worked in the telco industry, over there they were using SaaS infrastructure. So they have SaaS enterprise, minor, etc. So they have a different warehouse over there. They were using Teradata database over there, and for different ETL process they have different pipeline which they were using, etc. But when it comes to one of my use case from the manufacturing company, so they have recently they have moved towards the big data Apache Spark data frame. So over there everything is there. They have the developers who were building pipeline. So being a data scientist, you can chip in to that, because you cannot learn everything. You should be enough in your own particular domain, and then you should have the support from the other domains, because I do not know anything, not but most of the thing I do not know about from the DevOps. So for those things we really need some support from the DevOps teams, because they have expertise in it. I have expertise in the predictive model. I can tell that this model is good, this is not, what are the reasons, etc. And I can help with the data quality issues what are happening, and then I can propose them the engineers how they can improve. So again, it's highly depend on the infrastructure, what industry is using, and based on that what are stuff, and either for the deployment, most of the time, like for follow the pipeline in Microsoft here, and over there they have so we follow that. But for other client, if they do not have infrastructure, then we set up a manual process for them for the deployment.
Okay. So thank you once again, Sano, for all that interesting topics that you have brought us today. See you soon and looking forward.
Thank you very much for your time. See you guys.
Bye.